In this video we're going to consider the tangents and normals to curves. So a tangent to a curve is a straight line which just touches the curve, and at the point where it touches the curve we say that the gradient of the tangent is equal to the gradient of the curve. So the tangent is a straight line, so we're going to use the formula y minus y1 is equal to m lots of x minus x1, and the required information there is a pair of coordinates and the gradient. So we've got the x coordinate and we've got the equation of the curve, and these two bits of information are going to allow us to find the rest. So when I've got the x coordinate of 2, to find the y coordinate I'm going to substitute 2 into the original curve. So that will be 3 lots of 4 subtract 2, 12 subtract 2 is 10. So 2, 10 is my coordinate that I'm going to use. I'm also going to have to find the gradient, so dy by dx is going to be 6x, so that's 2 multiplied by 3 gives me the 6, reduce the power by 1, and then the number term disappears. So at x equals 2, dy by dx is 6 lots of 2 is 12. So now I can use the formula for the straight line, and I can say that y minus y1 is equal to m lots of x minus x1. So y subtract 10 is 12x subtract 24. So y is equal to 12x subtract 14. So in the second example we're asked to find the normal to the curve. So we need to know what the link is between a normal and a tangent, and a normal is perpendicular to a tangent. So I'm going to go through much the same process as I just did when I found a tangent. The only real difference is going to be that I need to do -1 divided by the gradient that I obtain to give me the gradient of the normal. So I'm going to substitute 3 into the original, and this is going to give me the coordinate that I require. So that gives me 15. So it's 3, 15, which is the coordinate I'm going to use. And then I'm going to differentiate to give me the gradient of the curve. And then I'm going to substitute in the x coordinate, and so that's given me 23, and I'm just going to record here so that the gradient of the normal is going to be -1/23. And now I can use my equation, so y minus y1 m x minus x1. So y minus 15 is -1/23 x minus 3, and I'm just going to multiply through by 23 so I don't end up with all these fractions. So 23y, and this is going to be 300 and 45, and that is going to be negative x subtract 3. So 23y, subtract 345 is equal to negative x, add 3, and I'm going to write it in the form x plus 23y subtract 348 equals 0. And this is the equation for the normal to the curve at the point where x was equal to 3.